To make it hang Ryan, make it set.
Yeah, that'd be a good idea, actually. I already have Firefox up with the wall.
Don't make fun of the flip flop.
Know what you're doing. Give me a second. I just.
General Fredo and Fredo.
It's set up till 10 after 12. I knew I was in front. So I apologize for being late. Wanted to start, though, with something I just saw in this month's issue of Bulletin of the AMS. The cover story was interesting because it says here, typical gaffe about tornadoes. And the story is that most media people mistakenly describe what tornadoes are caused by saying that they're caused by a clash in air masses. So this article is about what to say instead. And the conclusion was to say this. Yesterday's storms occurred when warm, humid air near the surface lay under dry air aloft, with temperature decreasing rapidly with height, originating from higher terrain to the west or southwest, providing energy for the storms through the production of instability. Large changes in wind with height over both shallow, lowest 1 kilometer, and deep through the lowest 6 kilometers, combined with the instability and high humidity near the surface, created a situation favorable for tornadoes to form. That illustrates the problem we have in the media, that if somebody wants a 5-second or 10-second explanation of something, can't do it with this, even though this is the accurate way to do it. So it's a challenge. Today's weather forecast is a challenge too, and I've no answers. The interesting thing along the East Coast today, an area of snow came through New England this morning, caused a lot of disruption in coastal New England, southern New Hampshire, eastern Massachusetts, and its main problem was the way it was timed. If it had occurred at 10 or 11 o'clock last night, would have been no bother. But what happened is some warmer air came in, so temperatures were just above freezing. They have all the snow sitting on the ground like glaciers, and people can't even see out of their driveways. And roads turn into a sheet of ice. What sometimes happens in cases like that is schools will decide to dismiss early. And if they're not getting a good weather forecast, which I think they were from the National Weather Service today, said exactly it would clear up later this afternoon, they would dismiss early right in the time when it was worst outside, even though it was going to improve greatly in the afternoon. But sometimes that's a hard call to make. When you see it snowing hard outside, you believe that it's snowing over the entire earth. And it's not snowing outside, as people in New York City saw early last week. It's snowing nowhere, even though it may be coming down 2 or 3 feet every few hours. Well, not every few hours, but just 20 miles away. So here's this storm forming just off the coast and moving away. And we see very clearly exactly what this next storm from the west should do, don't we? Help. What is this thing going to do? You see one piece of energy looking like it's breaking off through Nevada and heading into New Mexico. A lot of moisture coming into the Pacific Northwest, and some rain coming down to California where they could use it. San Francisco had the first completely dry January they've ever had. They'd never had a January with 0 rainfall before this. So quite unusual for them. And now what is this thing going to do? And I think the basic idea is first, after this blast of cold air comes down tonight and the wind dies off, temperatures plummet, starts to warm up a little bit tomorrow afternoon from west to east. Places like Chicago will get just toward 30 or a little past there, and we'll get back past 20. And then on Saturday, some milder air will come in. Some of the models are showing the temperatures at 850, boulevards getting up to 40, 45, 50 degrees Fahrenheit on Saturday, while at the surface it won't be able to warm up. They'll be close to the freezing rain boundary. Won't get that warm over here, but it'll be warmer than it is now, certainly by quite a bit. And then warm air stalls out, and slowly a high pressure area moves across central Canada, and there's tremendously cold air in northwest Canada and Alaska. Does anybody know some of the temperatures up in Alaska? Don't even have to tell me the places. Who thinks it's colder than minus 80 Fahrenheit? How about minus 60? 50. Just below minus 50. The next question I was going to ask is, how many are uncertain? How many don't care? And how many won't answer regardless of the question asked? All right. Well, anyway, as long as that cold air is sitting up there, there are high pressure areas that are developing every few days in that part of the world and heading southeastward, and they're being the cold air is then being channeled in toward us repeatedly. So that high pressure area comes down in south central Canada, moves across eastern Canada, and that sets up a northeasterly flow of chilly air for the whole northeast, it appears, in the Sunday, Monday, Tuesday period. South of that, there's this boundary between the cold air that's just come in and the warm to the south. And the question is there going to be an impulse that's able to make it spin up into a major storm like we've had the last two Sunday, Monday periods? Or will we have a series of waves, each of them fairly weak, but able to cause some snow to fall? And this is one of the situations where I think you see the strength and weaknesses of ensemble forecasting. If you, for example, look at all the different members of the ensembles as to what it's predicting for as far as a surface pattern, you'd probably see a tail of pointing one way or another of exactly many solutions may show a storm forming, a few solutions may show an outlier that there's nothing, and there may be one or two of the solutions showing something that is quite bizarre. Take an average of all of these, you're not going to see the extreme storm form in a pattern like this, because some of the modeling showing a wave forming on Sunday, causing snow in eastern New England, then heading out to sea. Others are showing a more important wave forming on Monday, and another showing a few of them occurring from Sunday through Tuesday. And so if you average them all out, none of them look spectacular, and the total amount from any one storm isn't that great. So the average is unlikely to happen. And so it's a case where you have to look at all the different possibilities, see how they're unfolding over the next few days, which way are the ensembles heading? Are more members heading toward one solution than another? And then make your best forecast. And then, of course, there are multiple models, and we know all about that problem. So let's look at a couple of them. Which model shall we look at first?
If you go to the tabs, Elliot, the GFS, the Canadian, and the European are all open. So,
all right. The tablet's top?
The one to the right, just to the right of that one. That one right there, yeah.
Like the one that says model data?
Yeah. That's GFS, and if you scroll down, you can go hour by hour with it.
Okay. Scrolling over here?
Yep.
Oh,
And just
okay,
hover over
right.
the time.
Okay. So this is GFS, right?
Yep, 12Z.
Okay, now, well, most of this before. Here's a situation later today. Our storm is offshore. It's a high pressure area building in. And let's say we're making a forecast for Pittsburgh. How many would think that there'd be snow flurries later tonight and tomorrow morning with that surface map? How many would not think there'd be snow flurries? How many think that if there were snow flurries, they'd be minor? How many think if there were snow flurries, they'd be substantial and might mess up the morning commute tomorrow? Okay, so basically, it's either no or there might be a few light ones. How about Buffalo? In that case, the wind direction actually becomes favorable for some lake effect. The lake's frozen. That cuts down lake effect quite a bit. It doesn't completely eliminate. There's still differential friction. It's much easier for the air to flow over the ice surface than over the hilly terrain just inland. But there's certainly not as much energy available as there is when the lake's open and you're getting evaporation. So the wind becomes a little more favorable a little after this time step. Right there it is not for Buffalo. But if the high pressure area goes across Ohio and PA, then it does become southwesterly tomorrow. And it's still cold. But really, it looks like, look at all that warm air that'll come out of Texas, New Mexico, head northeastward. It's just open and there's not a lot of moisture there. There's no flow from the Gulf, so it doesn't look like it clouds up right away. So as we proceed through this, we get out to tomorrow morning. This is tomorrow morning.
Yep.
Should be. And the warm air is proceeding northeastward, and we see the west-southwesterly flow across the lakes. Eventually, there's enough saturation occurs that you get some snow showers across the upper lakes where the Arctic air is holding in. Still see the precipitation coming in through the Pacific Northwest. And then we get to Saturday morning. Here's our frontal zone. Where would we draw a warm front here? Any ideas?
Omaha.
Omaha?
Maybe a little Sioux Falls, like that.
And then from where to from there?
St. Louis and call it quits.
I like that sort of. This is a kind of tough one to draw because if you look at the various equations, the flow at the surface and say aloft, say 500 millibars should be parallel to each other because you're in a uniform air mass and it's neither veering nor backing because the air is uniform in a warm sector. But on the other hand, there's still warm advection going on in that warm air advection going on in there. And typically, if you're in the warm uniform air mass, it's neutral. So the true warm air mass is down there in Texas or New Mexico. But you don't really see any real trough developing where the frontal location would be. So it's a tough one. But anyway, it's warming up across the Ohio Valley. And then we proceed along. And here's midday Saturday. And that leads me to something I heard on the radio on the way over. I was listening to one of the local stations. Fortunately, I wasn't on it. If it were, you wouldn't have been able to understand me because I was hoarse this morning. And but they were talking about snow for Saturday, and that it could be significant.
Saturday?
That's what I heard on that B94. Now, I think that they were thinking farther ahead, but there does not look like there's significant snow around here Saturday, if this is true. Maybe there's some freezing drizzle. If there's a thin veneer of freezing drizzle around here, that is significant. But it's not a lot of snow. Looks like there's snow forming, though, across the upper lakes. But there's that high pressure area north of the lakes, and we'll see what happens after that, so that by Sunday morning,
That's cold in the 60s. And further south.
the high has gone. The high is in eastern Canada now. There's a cold, low-level flow all the way along the New England coast, south into Pennsylvania. Nothing will stop the chilly air. It'll go into Virginia, too. And then on the west side of it, the whole frontal zone is sagging southward. And so it's beginning to look like there's maybe some wave forming. You have the warm air in place in the Carolinas. It's not that warm, but there's warm air there. There's definitely a northeasterly flow across Indiana and Michigan. And there's a huge area of mainly light snow from Pennsylvania over into New England.
Well, of course, if you look at the 6Z, this is a huge shift south and west.
It had been farther north than this.
I wonder if the anchoring high kind of concept in the north is below the track further. That's interesting. That's a huge change. I'm dying to see what the precip types are.
Don't die.
What?
Don't die.
Okay. Very high.
But no, it's amazing because I think we've seen this go back and forth the last several days. Some of the solutions have been south, and I think yesterday and last evening they appeared to shift northward, so that not much would happen here. It would all be in New England, and now it's back south again. And of course, we're not looking at any other members of the ensemble. This is the operational run. So we continue on, but if this is true, then on Sunday morning, it should be snowing around here. And this is actually Monday morning, so I'm looking at the wrong day. Let's go back. Here's Sunday. I apologize. The cold air is just beginning to push in. Then we go to Sunday night, 7 p.m. Sunday, 6 o'clock Central, 5 o'clock Mountain, check local listings. And the snow starts to break out in here, And then on Monday morning, as all Bostonians know, it's going to be snowing. Snowed the last 2 Mondays. They got buried. The 7-day period, more snow than ever before. Although we did check records that 10,817 years ago, during the Ice Age, that there was a deeper accumulation than at this time, but weather records weren't being kept then.
I bet Oak wrote that in stone.
So, that low pressure area then starts forming. And what's that feature that is in western Pennsylvania to western New York, the place where the isobars are going up and then coming back down? What do we call that? How many say that we don't know what to call it? How many call it an inverted trough? Okay, that's what it is. And actually, what's happening a little bit, the cold air is being dammed up east of the Appalachians. Then just west of there, the air is coming downslope and warming slightly, and so the pressures more easily fall there. See this with so-called secondary low pressure areas. When a trough comes in from the west, you'll see the storm approach through the Ohio Valley. Pressures will fall rapidly right up to the mountains. Cold air holds in a wedge over eastern Pennsylvania and New York. We saw this earlier this week. And then off the coast, the same height falls are able to produce great pressure falls out over the warmer waters of the ocean, and the second low pressure area forms. And it's tempting to think, well, if the secondary forms, it's going to keep snowing. And actually that doesn't work, because actually what's happening if the low pressure area is forming, that's probably a sign that there's some warming taking place. But the low level flow on the northwest side of it will be northerly. And so what happened, for example, this past Monday in New York, looks like all this warm air is coming in. Secondary storm forms off the New Jersey coast, and suddenly, about 7 or 8 in the morning, you start seeing a few surface temperatures coming down again. And like it had gotten to 34 degrees in New York and 33 in Newark, and low pressure areas straight to the west, you think, okay, it's just going to rain that day. And then the next hour it's 32, and then 31, and you see that the wind's actually northerly. The low-level cold air is coming in just the lowest few thousand feet from Connecticut and the Hudson Valley, and suddenly there's a sheet of ice. So that's what they had the other day in New York City, just ice the rest of the day, until finally the whole air column got cold enough and it snowed. And then we might forget about that ice until this morning. That ice was coating many buildings and bridges and trees. So what happens today when it started warming up above freezing for the first time? That ice starts to cut loose. If you're walking down the street in New York City and a chunk of ice falls from the top of a 50-story building, you don't want to be underneath that at that point. They even have special crews that go out on some of the bridges to knock the ice off so it doesn't fall on the passing cars. So those are the kinds of things you have to think about when you're forecasting for certain uses. Okay, so this is Monday morning. And let's see how many think from this point we're going to see a large storm developing by Tuesday? And you can only answer if you haven't looked yet.
I haven't seen this one.
Yes.
Yes. How many say no? Okay.
This verifies no.
What? And what's the question?
This map verifies no.
Well, the next day's map, and we'd have to do it by just sort of thinking to ourselves whether it's strong or weak.
Yeah, I'm just thinking if you get to this point, it doesn't seem like you'll get to a great storm.
Oh, okay. So the answer would be no.
But there's a lot of easterly flow, so it's going to be long. Yeah.
There could be a fair amount of precipitation. You don't have to have a deep low to get that. And at this point, for example, a Boston radio station was asking me this morning, how should we plan for Monday? And what I asked the station manager to do is the first thing to plan for was listening tomorrow. Well, that's actually, there's a lead-in for every promo and a promo for every lead-in with media, and it's always good to attract people, get them to come back. And it's not always because it's that you're going to tell them something exciting, but we know more with each successive day, hopefully. So it's probably going to be snowing, but whether it's a major storm that shuts down the city or just a few inches of snow and they can get by and they don't know where to put it still, then that's one of the issues. So let's proceed on. We're now going to go to the next period, which is 18Z Monday, 1 o'clock. Strong easterly flow. Looks like the low pressure center is out at sea, And at this point, it looks like the no answer is working out. Then in the evening, cue the music. We have to have the excitement building as we look at this storm forming. It would not be exciting if a large high was building, and I'll tell you that. Everyone might like it out there. We'd have to remember if we were talking to them. But among meteorologists, forecasters, okay, this is fascinating. The next map shows the low pressure area looking like it's going away, and then it continues to look like it's going away. So what happens is, what this says is, the easterly flow that sets up and causes some snow to develop, it could be a steady snow for a while or even all day, into parts of New York and New England. Eventually it just sort of weakens, becomes lighter, flow becomes more northerly, there's less flow off the ocean, and chilly dry air just takes over, if this is correct. And there it goes. Finally, it looks like it is taking shape out over the ocean. By this time, it's sending snow into Nova Scotia, other parts of eastern Canada, but another one of these high pressure areas is breaking off from south central Canada. And then for people who want it to snow, people who want tons of additional snow to fall, their excitement suddenly wanes a little bit, but there's more to the west. Another boundary will set up. Question? Okay. Now let's look at another model here.
Next tab to the right, I think.
Going to be the next tab to the right here is
Canadian, I think.
Canadian. The Canadian received a big improvement to it last year, and it has often done fairly well. So we'll look at it. Okay. Where are the times down here?
You have to scroll down again.
All right.
Yep.
Okay, so here we are with today. Always like to look at the first thing to make sure that it looks realistic. And this is for this afternoon, 1 o'clock. The high builds in. Here we are tomorrow morning. There's the west-southwesterly flow across the Ohio Valley and lakes. We get to Saturday morning. See the boundary getting established from central Wisconsin down toward Pennsylvania, and precipitation coming down along close to the snow-rain boundary, actually. And a very tight gradient of thicknesses in southern Canada, where there's very cold air to the north. Then we get to Sunday, and this says that much of the activity is occurring to the north, all across New York and into New England. That's farther north than the GFS had just been saying. See if that trend continues. We get to Monday morning, and it does settle southward. The low pressure area is sitting over Philadelphia or so, or Baltimore, and all the precipitation is across northeast Pennsylvania into New England. A lot of the public is very confused about the idea that if you're near the center of a low pressure area, why it isn't doing anything. And I have this analogy to somebody digging holes ahead of in the ground. If you're trying to dig a hole, you shovel the dirt out and you put it out ahead of you. Now, you might not want to put it out ahead of you because then you'll have to dig that up too. But in any case, as you're digging along, you're developing a trough, but behind you, if you're filling it in behind you, which the air is doing, pressures are rising, the amount of soil is rising, and so it dries out there. So it often will dry right behind a storm of all our precipitation ahead of it. So when we talk about a storm centered, say over Memphis, and to be over Philadelphia tomorrow, many people will think, well, tomorrow we'll have the worst weather, when actually it would probably be tonight as the storm was approaching. Same thing happens a little bit with tide forecasts, and you hear this on TV and radio sometimes. Let's say people are worried about tidal flooding, and they'll say let's say high tide's at noon, and you'll hear a report at 11:30, and they'll say the water is now lapping up over some of the seawalls, but high tide's coming at noon. Who can make a case that that's not a particularly valid thing to say? who thinks it's the exact right thing to say because the high tide's only half an hour away? Who's not sure?
So if the wind is steady,
The wind is steady.
then I guess that's unsure.
It's a concern because the tide won't be able to go back out very easily if the water is being blown against the shoreline. But the tide, in terms of the tide itself, the actual height of the water against some standard height is not going to be very much higher a half hour later. It's just like with the sunshine, the height that the sun appears to be in the sky. In June and July, it almost looks like it's steady, whereas right today, in fact, starting solar spring, the quickest rise from day to day occurs in the next few months. So anyway, when you're a half an hour away from high tide, it's pretty much as high as it's getting. Okay, so the next day, is a big storm forming? And this answer is no, it is not. It's forming well out at sea, so that's two models. Let's take a look at another one. And I'll bet that's the next tab, isn't it?
You have to exit out of this one, I think, now. If you
Right here?
just click the X in the top right. That's the
Okay, the Euro, was this last night's?
Yeah.
Okay. And scroll down to find the times. And here we are. These shaded areas of precipitation are, in this case, in the 6 hours up to that time. That doesn't mean just because it's green there across eastern New York State that the model is predicting it's going to be snowing at that time. It's saying that in the 6 hour period up to then, we're getting the snow. And that can be particularly deceptive in periods, say, when we're having showers or squall lines coming through. They're moving very, very quickly. If you look at any one of these snapshot pictures, you get the idea it's raining over a big area when really you may be having a 15-minute thunderstorm coming through. The higher res models from the various rapid refresh versions show that better with the simulated radars. I think that stuff's great, as long as it's correct. The more detail you show occurring at a certain point, and the more reliance you put on it, the better your chance of hitting something extreme, but also the better the chance of having an extreme error, because if it's off by just a small distance, we've seen these cases where there are very thin patches of rain, like around here last summer, might be pouring over the east side of State College and washing out creeks. The west side may not be. Now, the model may show that that kind of thing is going to develop, but the exact location is not always going to be right on that. But with all the research that many of you are going to be doing, that problem will soon be solved. Right?
Sure.
No, it's fantastic work that's being done. Okay, here we go to Saturday. That's Friday night, rather, tomorrow night. And we don't see any precipitation across the northeast. We shouldn't. And then the next night, here's Saturday night. We see the same area of precipitation developing, where the warmth from coming across the plains is coming up to the cold air north of it. Air is rising, and we get our cooling, and precipitation breaks out. And then we get to Sunday afternoon. Looks like most of it northeastern Pennsylvania into New England. And this is a model I think that a couple of days ago was most showing the idea of a major storm developing along the coast. And in fact, first it looked like it just might be a repeat of the storms of the last 2 Mondays. But now, more recently, that has changed. And indeed, this one, even though a storm does form, it's a little closer to the coast. There's a lot of cyclonic flow coming against New England at that point. So the snow would be heavier than, say, on those other models. But the position of the low pressure area is not really that different until you get out here toward the end. And this looks like the storm's moving away, but that's close enough in my mind that here's today's Thursday, looking at next Tuesday. Can we really trust it's that far out there? If it is, they're getting fringe snow at that time. They're getting a lot of cold northerly winds, not much really happening on land. If the storm's farther west, everything changes again. and then it moves away. So that's basically a look at all the different runs, showing that first we have the cold night coming up tonight around here. Starts to moderate tomorrow. Gets milder on Saturday, probably a lot of clouds showing up. Then some snow does break out on Sunday, lasts into Monday. We don't get a great deal. And, of course, we haven't gotten a great deal out of any of these storms recently. And as you go over into New York and New England, especially closer to the coast, they start to get snow and probably get somewhat heavier in the Sunday night, Monday period. And they would have a disruption for their rush hours during the day Monday. It's usually a safe thing to say that for a city, though, because even when it's totally dry, they typically have a tough rush hour. So that would be the briefing for today. One other thing I noticed when looking at, I sometimes look at music videos to see where they're taken. And so if you can tell something about the weather there, and there's a song out, her name is Eden XO, I'm not sure if that's her actual last name, but it's called Not Too Cool to Dance. But it's filmed somewhere in Los Angeles, and it just looks all hazy there. And so you could, if you looked at the picture, you'd almost think that that is the part of California where the video is taken. Certainly it wasn't taken in some pristine forest where the visibility might be excellent. Of course, it might be too cool to dance there. Questions?
Any questions for Elliot?
You just running on some of it, but I've noticed most of these winter storms have predictability horizons been on the order of a few days. We're still 3 days out, I think. They'll change noticeably.
Because these are only the operational runs, and as we get closer, there will be more information. We'll see if it really does consolidate. So at this point, we probably want to be predicting snow.
A lot of people jumped in that EC run yesterday. There was some ridiculous snowfall levels on the television, 24 inches of snow.
Well, I've seen that at AccuWeather on our automated forecast. It comes out with these accumulation numbers like 5-6 days in advance, and it's just frightening when I look at this stuff because we have to, when we actually put these out to customers, like through the radios, we delete these headlines because there's no reason to be predicting that kind of thing and no basis for it, and it's probably going to be wrong. And the totals look funny too, just because of the way the coding goes.
All right, Elliot?
Yeah.
So just
I can bring this over.
So I guess the new GFS is being out for 3 weeks, 4 weeks. So just, you've looked at a lot of models in your career. Any thoughts in the first 2 or 3 weeks of the upgrade to the GFS?
Wrote up about the model, they didn't really expect you to find a great deal of differences. I think that they said that. And I did see a couple of comments. I think last year's AMS president, I forget his name. Okay. He tweeted about how the GFS, with its new physics, it was much better on the storm that missed New York City than the other models. And it did show less snow falling in New York City than other models did. But my recollection is that it showed way less snow for Boston than they wound up getting. So it was just dry throughout its whole run. So in a place that turned out dry, it would be exceptionally good then. But it seems to be reasonable a lot, and many times in the past people wanted to throw out the GFS. So progress is being made, and it's up to the students of today and tomorrow to take this progress. When I started, there was one model that we used, and it's called the Barotropic Model. There's no advection going on or anything, and you looked at where these vorticity maxes were going along, and sometimes you were right and many times you were wrong, and to get a radar loop, you had to get a facsimile piece of paper, 3x3, from each radar by a telecopier, sort of like a fax machine by phone, and then paste them up on a sectional map to get your mosaic. And it was very busy then to try to do that. And we also plotted surface maps by hand. And that was fun. People had contests of how much data they could plot in an hour. None of which needs to be done today. Although, if you were looking at the maps on the computer, what are you doing with the other 58 minutes of the hour that you were doing before when you were plotting it and seeing what the weather was doing?
I have one really quick question. question before we wrap up. I know you spend a lot of time forecasting for Boston, and I'm from the Boston area. And I think the thing that concerns me the most with the setup early next week is the persistent easterly flow, because I've seen cases, especially when it's cold, temperatures in the teens and 20s, that along like the North Shore. Has there been any thought about maybe that in some places seeing, localized extreme too early to hone in on those finer details?
I think that could occur. I think it's very reasonable that some places they're going to get another foot of snow. It may be spread out over a few days instead of a few hours.
Right.
But you can get an awful lot of precipitation, and you get that coastal trough forming. Look at earlier this week when it's like 35 degrees at Nantucket and it's 15 degrees at Bedford, Massachusetts. Just a tremendous difference. So sure, that's a big worry.
Great. Thank you, Elliot. Thanks very much, everybody, for coming. We'll be back here next week. I actually don't remember the speaker. I should look into that. But there will be an email and a reminder coming out next week. Thank you.
Thank you, Ryan.
Appreciate it.